Hello and welcome to our webinar. Today we're going to talk about deploying Oracle RAC 19c on Azure Cloud using SkyCluster. My name is Art Danielov and I'm CEO and CTO of FlashGrid, and I will be presenting this webinar today. If you have any questions during the webinar, please send them to us at the email address that's shown on the slide, and we will answer those questions at the end. All right, so what is SkyCluster? SkyCluster is a high availability solution that provides active FA with 2 or more database nodes, and it is based on the proven Oracle RAC database engine. And it is deployed using the infrastructure as code approach, so you can easily deploy multiple clusters with minimal some customization done to each of them, and you can easily redeploy them. And we have full automation of the deployment process. So what SkyCluster effectively is, it's an engineered cloud system, or you can also call it a virtual cloud appliance. It is engineered for high availability with no single point of failure. There is a lot of focus on testing the reliability of the cluster, and we put a lot of cycles into making sure that the solution that you get is works out of the box, and you don't need to worry about it reliability aspects and compatibility with other components of the system. And there's also a lot of focus on performance. And it comes with 24/7 support that covers the entire infrastructure stack, not just the proprietary SkyCluster software pieces, but all of the entire infrastructure stack. So here is the high-level view of a typical cluster. So it's a simplified diagram. You can see 3 nodes here running on 3 virtual machines. So each virtual machine has disks attached to it, and it has those are the disks that will be storing your Oracle database data, and it has full Oracle stack running on them. Now, there are 2 main software components from FlashGrid that enable this type of solution. The first one is called Cloud Area Network. Cloud Area Network enables some more advanced network capabilities that are required for running RAC, but that are not available natively from Azure. More specifically, those are multicast, the virtual IPs, and moving those virtual IPs transparently between the nodes, and also quality of service for different types of network traffic. The second software component that you can see shown here is Storage Fabric. So what Storage Fabric does, it takes the disks that are attached to individual VMs and turns them into shared disks. As you probably know, Oracle RAC fundamentally relies on shared disk access between all database nodes. But again, in the Azure cloud environment, you do not get shared access to disks. So Storage Fabric solves that problem, and also it integrates very seamlessly with ASM, so all those shared disks are exposed directly to ASM. And then we also leverage the capabilities that ASM has for high availability of the data and for data mirroring. So we will get data mirrored across these database nodes, so that if one goes down, the other nodes still have one or two copies of data available to them, so that the cluster can keep running. So on this particular slide, what you can see is that these three nodes are spread across three availability zones. So this is what's called a multi-AZ deployment, where, as you probably know, availability zone is an Azure concept that effectively each availability zone means a separate data center within the same region. So all three availability zones are in the same region. But these are separate, physically separate buildings that are close enough to keep latencies low enough and keep the network throughput high enough, but they are still separated. So in case there is some local disaster, only one node will be affected, the other nodes can keep running. However, not all Azure regions today support availability zones yet, and some regions support only what's called fault domains. So fault domains are separate domains within the same data center building that are still isolated from each other with some fault isolation at the infrastructure level, at the from network and power perspective. So the chances of the failure are of more than one fault domain at the same time are fairly low. So we can support both of these architectures, and it is just depending on which region you're planning to use, or in case you prefer to use fault domains versus availability zones, and in some cases there might be benefits due to somewhat lower latencies. We can support either of the two deployment models. One question that we get asked is, what if we use availability zones? Don't we get low performance? And the answer is that in most cases the performance is still good enough and fast enough because the latencies between availability zones, even though those are separate data center buildings, the latencies are typically under 1 millisecond. So it's still good enough both for storage and for the cache fusion traffic. But if super fast performance is needed, then you can use the fault domains approach. Now let's talk a little bit about the HA architecture. So there is no single point of failure, like I already mentioned. Also, there are 2, 3, or more database nodes that can be used in parallel. The most typical scenarios that we see are in most demand are 2 or 3 database nodes, but we can do more than that if needed. There is also 2-way or 3-way data mirroring done at the ASM level. So like I said, if you lose one of the nodes, or maybe even two, you still can have uh, one or two more data copies up and running so that the surviving nodes and database nodes can continue operation. You get the rolling patches. So if you or when you need to patch your database or your operating system, you still can do that one node at a time. So you don't have to have any downtime associated with patching. And of course, this HA architecture protects you against such unexpected failure scenarios that could be just virtual machine or a physical host failure. It could actually be planned virtual machine reboots that are done by Azure when they need to retire the physical host or maybe apply some security updates. If you use the multi-AZ deployment, then it can also protect you against the failure of an entire AZ. And of course, things like database crash or operating system crash, system disk or file system corruption that could happen, and you do not want to have downtime when it happens. So you get protection with this architecture against those scenarios. We try to make this solution very Oracle DBA friendly. You get the full RAC stack that you're familiar with, including ASM and clusterware. You also get to use the familiar tools such as RMAN for backup, DataGuard for disaster recovery replication, Golden Gate for replicating data to between different types of databases, and also Oracle Enterprise Manager for managing your databases. You do have full control of all database features and the patching process. The patching process is pretty much standard. There is we don't put any restrictions on it. And also, the elasticity of the cloud gives you the benefit of quick and easy storage expansion, because as this is probably one of the most frequent maintenance operations, is just adding more storage as your data grows. So this can be done very easily on Azure by just adding additional disks to the VMs, and they automatically get exposed to ASM, so you can add them to an existing disk group or create a new disk group. And on top of that, we have our support team that has very deep Oracle expertise. So we can help you not only with the infrastructure stack, but also with all the ASM and clusterware related questions, and in many cases, database related questions as well. So performance-wise, we can support VM sizes ranging from the very small 4-core VMs to very large 64-core VMs. And similarly, the memory size can be up to 4 terabytes per node. So pretty much all the VM sizes that Azure supports. And we also have measured performance up to 140,000 IOs per second on a 3-node cluster with a read-write workload. Of course, the performance of the storage will depend on the number and the size of the disks that you select, but this gives you some reference point. So this is what you could achieve if you need that level of performance. And 140,000 IOs per second is comparable to a good all-flash dedicated storage array. So it is very much competitive against a typical on-prem setup. And in many cases, it actually is much faster. But what's important is that you can actually size your VMs and storage the way you think is best today. And later, you can resize it. You can upsize if your data grows, if your workload grows, if the number of clients grows. Or if you see that some of the resources are actually underutilized, you can downsize those VMs. And that resizing actually can be done even without any downtime by stopping and resizing just one node at a time. From security and control perspective, you have full control of the database software and the operating system. You have root access to the OS, and the virtual machines are deployed in your cloud account, and our team has no access to those VMs or your data, so it's completely in your hands. But also the data is encrypted by default by Azure Storage Service Encryption. And if you prefer to, and if you have the corresponding license from Oracle, you can use Oracle Transparent Database Encryption on top of the storage level encryption. Compatibility-wise, we support database versions starting with 11.2 and all the way through the latest 19C. And what's important though is that when you deploy a cluster, you get grid infrastructure version 19C already. So even if you deploy database 11.2 or 12.1, so that makes it easier to upgrade your database version later on when you need to, or if you need to. Because you will not have to upgrade grid infrastructure. It will be already 19C. You get a choice of Oracle Linux or Red Hat, depending on your corporate standards for the OS. We do support multiple, not just multiple sizes of the VMs, but also multiple types. So you can always switch between different types of the VMs if it makes sense for you. And we support not just the commercial Azure cloud, but also the US government cloud, as well as the China and Germany clouds. So SkyCluster comes with 24/7 support plan, and that includes, that covers the entire infrastructure stack. So it does cover the FlashGrid SkyCluster software, and it also covers ESM and clusterware related questions or issues, as well as Azure infrastructure, VMs, networking, disks, and also the Linux components related to networking and storage. And we also help you with performance-related questions, whether it is sizing of a new cluster or troubleshooting or optimizing performance. So we can help you with analyzing AWR reports and identifying any infrastructure-related bottlenecks and give you specific recommendations about how you can solve those performance issues. And the deployment is fully automated with SkyCluster Launcher tool. You can have the cluster running in just over 1 hour. Again, it is an infrastructure as code deployment. You get a template that you can keep and then to reuse for deployment of additional clusters or redeploying redeploying the same cluster. And what's important is that it helps you eliminate human errors, which is especially important in high availability configurations, because the last thing you want is to configure your HA and everything seems to be working until there is some new unexpected failure scenario that you have never tested, and things just and then you get a downtime. So that's a bad scenario, and having this tested, pre-tested, pre-integrated way of deploying a cluster is much more reliable from that perspective, so you can avoid those type of errors. Now, let me show you how the actual deployment is done. So give me a minute to start the demo. So it starts on our website. Under software, you can go to SkyCluster for Azure. And if you scroll down to the bottom, you will see two buttons, launch 2 RAC nodes or launch 3 RAC nodes. So these are the two most standard configurations, like I already mentioned. If you need a different configuration, then please just let us know, and we will help you with a more customized and optimized configuration to start with. But today we'll just start with 2 RAC nodes. And also, one thing I'd like to mention is that the software itself is delivered through the Azure Marketplace. So after we deploy the cluster, all the billing for the SkyCluster software fees and support comes through Microsoft. So let's launch 2-node cluster. All right, so this is a wizard that walks us through a few steps. Each step is pretty simple, and it just basically asks us for input about the desired configuration of our cluster. And in the end of the process, it generates an Azure Resource Manager template that you deploy in your Azure account, and it will create the cluster. So the first step is just some basic information about, the name of your cluster, the cloud where you want it deployed, commercial or government cloud or China, the OS, Oracle Linux or Red Hat, whether it is production deployment or free trial. And by the way, we do have a 1 month free trial, so feel free to use it. And you can apply on our website to get 1 month of support during this free trial, and the SSH key that will be used to access your VMs. So the next step is selecting which database version you want installed on this cluster. So you have a full list of various versions that we currently support, and keep 19C if you want the latest one, or you can select an older one. And also you can select the release update version that you want to be applied to your database software. Next is an important step. This is where we determine, based on the selection of the database version at the previous step, we determine the list of Oracle installation files that you need to provide to create the cluster. So like I mentioned, the deployment is fully automated, and that includes installation and configuration of grid infrastructure and Oracle database software. However, we do not distribute Oracle binaries, so we ask you to get your own copy from Oracle's website, and this is the full list of all of the files that you need for deploying database version 19c and applying the selected release update. So in this case, you can see 6 files. And there are hyperlinks to each of these files, so it just makes it easier for you to get those files. And once you have those files, you just upload them to a Azure storage container, and you just provide the address of this container here. So the next step is selecting, well, actually configuring your database nodes. First, we need to select whether your region supports availability zone, or if not, whether it has 2 fault domains or 3 fault domains. So the many regions already do support availability zones, and if you have an option of using one of those regions, that's what we recommend. Otherwise, you can select whatever is true for your region. And next, you can customize names, the host names of your database nodes, and also size for each node. And you can see here the full list of different VM sizes that we currently support. One thing that you'll notice here is that there is this third node which is called a quorum node. In this case, it is needed because we do need a third independent location for a third copy of clusterware voting files, and also a third copy of ASM metadata. And so this quorum node is a small VM that does not have any Oracle software installed on it, no user data. It's just this third copy of voting files and metadata. So in this configuration, any one of these 3 nodes can go down without causing the downtime. So it's a simple majority rule. 2 out of 3 nodes must be up. And the quorum node effectively serves as does arbitration between the 2 database nodes and helps us avoid a split brain scenario. The next step is configuring storage. And you define storage in terms of ASM disk groups. There is already a standard grid disk group created for voting files and for OCR, so it's mentioned here. So you don't need to worry about the grid disk group. Just need to focus on where your data will be stored and how much space you need for that and how much performance you need. So for each disk group, you can specify the name, and you can add additional disk groups or remove those disk groups. And you can also specify how many disks you want to have per disk group and the size of those disks. Note that these will be premium SSD disks. And you can also find a link here to an Azure page that describes the performance characteristics of those premium SSDs depending on the size of each disk. But the rule of thumb is that the bigger the disk, the more IOPS and more throughput it gives you. And also, as you add more disks, you also get higher aggregate IOPS and throughput, until you reach the maximum cap imposed by the VM itself. So by adding additional more disks or bigger disks, you can effectively max out the IOPS and throughput capability of the selected VM size. Next. We automate configuration of huge pages, which makes it easier for you so that you don't need to do it manually after creating the cluster or after resizing the VMs. So we make it much easier, and you just need to select the percentage of memory and the percentage of that is allocated for your SGA, and will configure huge pages automatically. You can customize the listener port numbers, or you can just keep the defaults. For the network, you have effectively two options. If this is a sandbox test deployment that does not need to, if the cluster does not need to communicate to any application servers, or then the easiest option is just to create a new VNet for the cluster. But if you already have an existing VNet, which is more typical for a production deployment, then you can specify the which VNet you want to use. So you just need to provide the resource group name of that VNet and the VNet name, as well as the subnet name, and also optionally network security group names and a list of application security groups. Next, you can customize the DNS configuration. You probably want to set some domain name for your hosts that makes sense in your environment, and also you can you can customize the DNS servers that are used by the cluster. By default, we use Azure provided DNS, but you can, if you prefer to use your own DNS servers, you can customize them here. And then we also need time servers. By default, we use the time servers provided by Google. But if you have your own time servers, then you can customize the list here as well. You can configure email alerting. So if anything goes wrong during the operation of the cluster, there will be email alerts sent, and you can specify which email addresses you want them to be sent to. And we also have what's called call home, or basically those alerts can be sent directly to FlashGrid support so that we can take more proactive action. You can also add tags for asset tracking purposes. Those tags will be attached to the VMs and the disks. And that's pretty much all we have to provide. So we just click validate configuration to make sure that the configuration is consistent, and we pretty much are ready to launch the cluster. However, before we do that, it makes sense to save the configuration that you just created, because what if you need to redeploy the same cluster? Maybe you made some mistake and you want to correct it. You don't want to go through the entire process from scratch. You can start with the configuration that you already created, and for that you just download this configuration file. So this is just a text file that will be saved on your laptop, and later you can upload it to this launcher tool using this upload link in the top right corner. And finally, we are ready to launch. When we click launch, what happens is that the Azure Resource Manager template is automatically generated, and it takes you straight to the Azure Resource Manager. And here, you just need to select the subscription that you want to deploy it into. We also encourage or strongly recommend creating a separate resource group for each cluster. And the reason for that is that if you decide to delete the entire cluster, maybe because you don't need it anymore, or maybe because you made a mistake and you need to correct the configuration and redeploy, it is much easier to delete the entire resource group, because there will be a lot of resources that will be part of this cluster. And of course, you need to select your location, basically the region, your target region. So after you have selected all this and you click the purchase button, the deployment process starts. I'm not going to do it now because it will take some time. But basically, first of all, there will be Azure VMs created and disks attached to them, and then the software initialization process starts. So creating Azure resources takes several minutes, and then there is the software initialization stage, where first the FlashGrid SkyCluster software is installed and configured. And second, there will be grid infrastructure installed, patched, and configured. And then ASM disk groups created. And then the database software installed and patched. So in the end of the process, you get a fully configured cluster that is ready for creating a database. We do not create a database for you because you probably already have your own database that you need to replicate or restore from backup. But we create a fully configured cluster that is ready for a database. So this is what it's going to look like. So I have a demo cluster created already. So in this case, we have 2 RAC nodes and a quorum node. And let me just connect to one of these nodes, and I'll show you what it looks, what's inside. Just give me a minute. All right, so we are connected to this node. This is the message that you will see after you connect, assuming that the cluster initialization had a chance to complete. And again, the process of software initialization takes about 1 hour. So here it's successfully completed, and you'll see a message like this. In case it is still in progress, or in case there was any failure, you will see a different message, and it will tell you whether you still need to just wait, or whether there was some error, and maybe you need to review your configuration or contact us for help. Let's switch to root, and let's see what we have. Okay, so you can see that there are all the typical RAC clusterware resources running on this cluster. And also, we can check some more details about the cluster itself. So we have a command called FlashGrid Cluster that shows you high-level information about the health of this cluster. So you can see that the cluster status is good, and there's this list of the nodes with name of each node and status for each node. So in case something gets broken on one of the nodes, you will see the status changing to either warning or critical. So it will let you know where to look for a potential problem. And also there is a list of ASM disk groups and also status for each disk group. We can also see more details about particular node. So in this case, we're running on RAC 1, and here you can see that disks that are local to this node and the disks that are connected to it remotely from the other nodes. What you will notice here is that the names of the disks correspond to, they consist of the host name dot the LUN number. So it makes it very easy to manage, so you really know where each disk is located and what Azure disk LUN number it corresponds to. And if we look at it at the operating system level, then these disks are all under /dev/FlashGrid. And you can see here a list of all disks that are available on this node. And what you will notice here is that the first 3 disks look slightly different than the other ones, because these are the local disks, and there is just simply a symbolic link pointing to the LUN device, just a locally attached Azure disk. And then there are these disks that are remotely connected from the other 2 nodes. And now let's look at similar list on the other node. So now this is the list of the disks on the second node. And what you see here is that the list is exactly same. So the same list of disks as on the first node, which you would expect, RAC expects to see the same disks. But the local disks are now the ones that are attached to RAC 2 node. Okay, and also we can take a look at details of a particular disk group. course, you can use tools like ASM CMD for this, but our own tools make it a little bit easier because they display information in a format that is more more relevant to this type of architecture. So what you see here is the list of disks in this data disk group, and also all the information about all the attributes of this disk group, and it knows where it's mounted. So it makes it a bit easier for you. And then you can also use the same CLI tools for adding disks easily, or replacing disks. So all this is available through our CLI tools that are basically just a wrapper around standard ASM engine. I guess that's all I was going to show you today. So thank you so much for staying with us. And now we are ready for questions. So please send us your questions, and I'll start answering them. Or I guess we already have some questions, so I'll start right away. Let me just read through them. All right, can we add corporate hardening scripts to the VMs? Okay, I guess we received this one even before the webinar. Yes, it is possible, and we have customers who actually have done that. So yes, we do have root access to these VMs, and you can add hardening to them. Once the cluster is set up on Azure, how do I populate it with data from my data center-based RAC database? So the process is very similar to what you would do if you had to move your data from a cluster running in one data center to a new cluster running in a new data center. What you typically would do, and some details might depend on your particular situation, but the most typical scenario is that you take a backup, RMAN backup of your database, and you ship that backup to Azure, and you restore it on the Azure cluster. So now you have the full backup, full database on your Azure cluster, except that it is not fully up to date. Now, if you're going to use it just for some testing, then that's probably fine. You don't necessarily need the latest data. But if it is a production cluster and you are supposed to switch over to the new cluster, then you probably want to establish data guard replication between your on-prem cluster to from your on-prem cluster to your new cluster running on Azure. And once the two clusters are in sync, you can switch over and make the new cluster the primary. Is there a published reference architecture for running Oracle RAC databases in Azure? We do have a white paper that provides more details about this architecture. So basically, everything I covered today, but in more detail, with more technical details, and with more examples of configurations. So we encourage you to check that white paper that is available on our website. When you say infra as a code, is the deployment solution built on Terraform? No, it is not built on Terraform. We use native Azure Resource Manager, and also we use a layer on top of it, which is our cluster configuration. So like you have seen already during the demo, you save that config file that basically all the parameters that you enter in the GUI, they are saved in a text configuration file that you can save in your version control system. And based on that, we generate an Azure Resource Manager template. In most cases, there is no Terraform involved. However, we do have some customers who do use Terraform for their infrastructure deployments. And in those cases, we just recommend embedding the Azure Resource Manager template into your Terraform templates. So think of it as the cluster, because the cluster is tightly integrated with all the components tied together, think of it as a single resource rather than a collection of resources. And that's why you just want to keep it as deployed as a single resource. Does SkyCluster consume compute resources on customers' Azure tenancy, for example, a separate VM, etc.? Well, yes. So effectively, it is deployed on Azure VMs. So each database node is an Azure VM. And also there is the Quorum node, which is a very small VM. But yes, those are compute resources on your Azure, in your Azure account. Is 30 terabytes of data too much for the architecture? Where is the database size limit? No, 30 terabytes is not too much. We actually have customers running databases of a similar size and even bigger. So there is no strict limit on the database size. But in more practical terms, I would say up to 100 terabyte is currently what would work fast. And the main constraining factor is the time it takes to load the data and restore it from backup, which is limited by the network and storage throughput. But from just pure capacity perspective, you can have even more than 100 terabytes. That's not a problem. It's just a matter of how long it takes to load the data. All right, I guess these are all the questions we had. Thank you everybody for attending and joining this webinar. And please, if you have any other questions, please feel free to follow up at this email, and we will respond to them. Thank you again. And one last thing I'd like to mention is we are also very happy to support you with proof of concept. So if you are willing to deploy a cluster today or next week, just let us know and we can help you with your test setup. Thank you so much and have a great day.